So what is a transformer? This is an example of a transformer. And a transformer is used to either step up or step down alternating current. So here I have, it's basically a power cable with a switch on it. This is 120 volts AC going into one side of the transformer. And there are wraps of wire in here, and we're going to get a different voltage out of the other side. So let's go to AC here. Stick our meter on. Got about 20 volts coming out of this side. Like I said, if I measure this side, we have 120 volts. So 120 volts in, and magically we're getting 19 out this side. Alternating current AC. So how does this work? Well, essentially there's a coil of wire. So the electricity comes in on the primary side, and there's a coil of wire. And the secondary side is also a coil of wire. But basically you just wrap the wire in a ratio. So we were getting 20 volts out of here, and it was 120 here. That's a ratio of about, what, 5 to 1, 6 to 1. So your primary side, for every 6 turns of wire, there is 1 turn of wire on the secondary. So you get that 6 to 1 ratio here. Here's an example of a little transformer. It had some blue tape that I kind of scraped off, but you can see that it's basically just wire wrapped around and around. So a transformer in its pure form is basically 2 coils of wire. There's a primary coil and a secondary coil of wire that are not conducting, but they're basically coiled up and set next to each other in a nice tidy package like this. How does that work? Well, there are 2 things you need to know first. Number 1, when you pass electricity through a wire, it creates a magnetic field. Just like how you can take a magnet and pick up metal objects or the magnetic field in the earth, it's the same thing, only it's created by electricity moving through a wire. We can easily demonstrate how to create a magnet using a wire or an electromagnet just by taking a piece of wire and a nail and wrapping the wire round and round and round. Okay, I am done now. So I've wrapped the wire around. The only important thing is that you have to, if you start wrapping in a direction, don't stop and wrap it the other way, because that will counteract the electric field. The magnetic field will counteract each other. So just go one direction only. The 2 ends of the wire. Here is a battery. So go ahead and see, not magnetic. Attach battery, and voila, we have made a electromagnet. Disattach the lead, no trickery. Number 2, if you take a magnet and pass it next to a wire, you actually create some current flow. Here's our handy electromagnet that we made in the first part of this video. So if we took a magnet and threw it on there, no, it doesn't create electricity. That would be too easy. But if you watch the meter, you'll see right when I do it, you get a little spike. So in order to create electricity, it has to be alternating. You have to hit it lots of times. Well, I cheated. Taking a drill bit and attached some magnets to it, and watch the wonder. Granted, this isn't much electricity, but it's proving my point. Look at that. We're creating some electricity with a magnet on the wire. So we know that if we pass a pulsing magnetic field next to a wire or a coil of wire, that we can generate electricity. So where could we find a good power source to generate this pulsing magnetic field? Well, it is no coincidence that the power that comes down the line and into your home is called alternating current. Alternating current, as its name might indicate, is alternating or pulsing, and it's doing this 60 times a second, which makes it perfect for use with a transformer. Back to our original question, how a transformer works. Well, essentially, there are two coils of wire stuck up next to each other. A lot nicer in this transformer, but you run alternating current, about 120 volts in the US, on one side, up to another set of wire, and you just need a ratio of wire. So if you have 100 turns here and 50 turns here, you're running 120 volts through here, you would get 60 volts here, because the electromagnetic field will transfer the electricity from one coil of wire to another.